Hey guys, today we will be focusing on permutations and I will explain what they are, and also I will come up with a permutation formula to find the total number of permutations. And I still believe that the best way to explain what permutations mean is just have a look at a couple of examples. Say you have been given two objects, let's say A and B. Now, these two objects can be rearranged in two different ways. You could either have AB or BA. Now, each of these pair, AB and BA, they are called permutations. So basically, a permutation is any arrangement of a set in a particular order. The vital important point here is that the order does matter. So if I swap the order of these two objects, A, B, so I would get completely different permutation. In other words, permutation is a way that any set of things or objects can be organized in a kind of sort of a linear fashion. So again, order does matter. So if you swap the order, so the permutation changed basically, and you would get, generally speaking, completely another permutation. Now, let's take a look at, and if you notice, in this particular case, if I have two objects or two things or two elements, two members, whatever you like, so the total number of permutations for two objects is going to be two, obviously. You have 1 and 2. And I could write it down. So the number of permutations equals 2 in this case. Now, let's take a look at three elements. Suppose you have been given three objects or three elements. So say you have A, you have B, and you have C. Now, these things can be rearranged differently. So let's swap A and B first. So you would get something like B, A, C. Now, we could also swap B and C. Also, we can swap A and C. We could swap C and B. BCA. Finally, we could have CAB. So CAB. Now, you could simply count them. So you have 1, 2, 3, 4, 5, and 6. So the total number of permutations for three objects is, and I drop everything. Total number of permutations for three objects, so 6. You could see this, that the number like goes up rapidly, drastically. So ramps up faster. Oh, something wrong with my English today. Goes up, ramps up tremendously, rapidly. Now, Say you have been given an object. So let's say you have been given something like 1, 2, 3, all the way up to n. So you have n different things and different objects, or you could treat them as numbers, whatever. Now, question can be raised. How many permutations do exist for a set of n elements? And the answer is n factorial. So n factorial. And if you are not familiar with the factorial, I will just give you a quick glimpse into this. So n factorial basically stands for the product of natural numbers. Starting from n, you multiply by n minus 1, all the way till you hit 1. So we usually pronounce it as a factorial, and we use this kind of exclamation mark. So it's a kind of a shortcut annotation for this long product. So again, we start with the n, the natural numbers that you are given, and you keep going, you keep multiplying all the way down to 1. So this is n factorial. And for the total number of permutation, usually we use capital letter P with a kind of sub n. So this capital P sub n stands for the total number of permutations for n objects, for given n objects, or for the set containing n elements. You could put it in this perspective. So that's the formula, and you could basically check it. So for the first example, your n equals 2, since you have 2 elements. So P2 for the first example, it's gonna be just 2 factorial. And all you need to do is just spell it out. So 2 factorial simply means 2 times 1, which is basically gives you that 2. So formula proves kinda. Now, let's check it for the second example. So, for the second example, your n being equal 3, obviously. So, all you need to do is just take this 3 factorial. So, kind of spell it out, wind it, unwind it. So, it becomes 3 times 2 all the way to 1. So, 3 times 2 gives you 6, so you could simply ignore this one. And again, this formula works for that second example. So now, if you are given set of 4 elements, for 5 elements, so you don't have to write these permutations explicitly, because you can notice that again, if n increases, so the number of permutations also increases, and it increases rapidly, because for example, for P4, you could calculate it for 4 elements. The number of permutations is gonna be 24. So, and it would take time and space to write out explicitly this total 24 permutations for the element, for the set, let's say containing 5 elements. So again, the total number of permutations would be, I believe, 120. So you might see that the number increases rapidly, not dramatically, drastically. Alright, now, as a quick remark, 0 factorial, sometimes when you do calculations, 0 factorial might come up, and 0 factorial is defined to be 1. That's important, and I just want to pay your attention, because many people, when they do calculation, they assume that 0 factorial is 0, and they fail of these calculations. So keep in mind that by definition, it's kind of convenient to just take it, to just by definition say that 0 factorial is just 1. Keep it in mind. Now, let's put it to the test. Most of the time, permutations come up when you solve kind of word problems involving arrangement of different things. Let's take a look at this one. How many 5-digit numbers can be formed using the digits 1, 2, all the way up to 5 without a repetition? Well, you could simply explicitly write all of these combinations, but it would take you ages. Now, since you're going to use these 5 digits to be precise, and basically what are you going to do? You're going to just swap the order. It's precisely basically the same idea, the same example what I did before for 3 elements A, B, C. You could basically take them as numbers. Now, all I need to do is just swap them between each other. So, and you might notice that the total number of all these permutations, so basically we're dealing with permutations at this point, it's going to be just P5, which is 5 factorial. Since I have 5 digits, and all I need to do is just rearrange them in a particular order, just by swapping them around. Now, all you need to do is just convert this factorial into multiplication. So, and again, as I mentioned before, you always start with this number that you are given, and you multiply all the way down to 1, not up. So 5, 4, 3, 2, till 1, until you hit 1. And all you need to do is just simplify it down. So 5 times 4 gives you 20, times 6. You could simply ignore this one at this point. Total number is 120. So it's kind of a huge number. So that's the total number of permutations for this problem. I would like to give you another way of solving this problem. And if you don't know what permutations are, and if you are not familiar with this formula, you could figure out this problem by using a multiplication rule. And by the way, I do have a video on multiplication rule for combinatorics, and the link will be down below in the description box, and if you need this kind of help, you could check it out later. Now, since I have to come up with a 5-digit number, all I need to do is just use kind of these slots. So I have 5 slots. 1, 2, 3, 4, 5. Now, the first place, I have 5 digits to be taken into consideration. So I could choose any of these digits. It could be either 1 or 2 or 3 or 4 or 5. So, and I could pick any digit for this first place. So if you notice, so 5 choices basically. So I have these 5 choices. I have these 5 different variations to pick, to select the first digit for my number. Now, since we are not allowed to use repetition, so since I've already, the first digit is chosen, I always have problems with this verb, chosen. I need to look up the dictionary. Since first digit is already selected, it's picked, for the second place, for the second slot, I have 4. The rest, I have 4. So I have 4 choices of picking digit for the second place. Now, 2 already chosen. So for the third place, I have only 3. The rest, 3 digits. Now, for the next one, I have 2. And finally, for the last place, for the last digit, because already we took other numbers, other digits. So for the last one, you would be left only with one possible outcome, possible choice. And all you need to do at this point is just multiply them. So you could simply apply this multiplication or counting principle, if you will, for combinatorics, and all that means you just multiply 5 times 4 times 3 times 2 and you could ignore this one at this point. So, and if you notice, it's precisely the same number what we did before, so it becomes just 120. So 120, it's the total number of 5-digit numbers. Alright, with this being said, I hope it has been helpful to you. Huge thanks for watching and sharing your brain. I know everyone hates maths, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you'll not miss out my new videos. What they are, and also I will come up with an example. Not with an example, with a formula, the permutation formula. Okay. Start over. And permutation, not an permutation, a permutation, or permutation. Yeah. Go back to school. And I will come up, why to take a note? Focusing on permutations. I still believe that the question can be raised: how many permutations do exist for the element, for the set? Okay. So the question. All right, good. Choose. Oh, anyway.